We're now going to look at the graph of tan x. Now the first thing I do is draw a tangent to my unit circle. Now we're going to make our angle here. So this is angle x. We're interested in what happens when we project this onto this tangent line. Now we know that tan is opposite over adjacent. So this is opposite and this is adjacent. Because the adjacent goes to the edge of the circle, remember that's 1. So the value of tan will be this height here divided by 1, which is actually just this height here. If I change to a larger angle now, that would be the angle, and I would project all the way up here to the tangent line, and the value of tan would be this height here. And I can carry on doing this all the way from 0 to 360 around the unit circle to plot the graph of tan x. So we start here with an angle of 0 degrees, and you can see that the height projected onto the tangent is 0, so we plot that here. With an angle of 30, the height projected onto the tangent is this, and that's here, which we plot at 30 degrees. With an angle of 60, you'll see that the height projected onto the tangent starts to increase quite rapidly, and we plot that here. And I keep going to 70 degrees, 80 degrees, and at 90, you'll see that our line is vertical, so nothing is being projected onto the tangent. The height is therefore infinite. So what's actually happening is that as we get closer and closer to 90, the value of tan x is increasing more and more and more rapidly. And actually, when we get to 90, the value of tan x is infinity. We can't plot that on the graph. Instead, we say that at 90, we have a line that the graph will never ever meet. We call this an asymptote, and actually it continues underneath the graph as well. Now what do you think is going to happen if we make this angle larger than 90 degrees? So let's do that now with an angle of 110 degrees. You can see that this line here, if I extend it, won't actually ever meet my tangent. But if I look at the other end of the line, it will, and I get a negative value for tan x. So I plot that on the graph here. I can continue in the same way until I reach 180 degrees, where the value of tan x is 0. So notice now that we're back to this point again, and the graph is going to continue upwards. What do you think is going to happen when I hit 270 degrees? Again, the line is now vertical and will not meet the tangent, so we get another infinity value and another asymptote on the graph. We've now completed a full rotation, and tan x is back to 0 at 360 degrees. Let's tidy this graph up now. So this is the graph of y equals tan x. And we have two asymptotes at 90 degrees and 270 degrees. You're expected to memorise the shape of this graph. Personally, I find it really helps to memorise the asymptotes as well, because this helps me produce this graph. Now the nice thing about the graph of tan x is that it repeats every 180 degrees. So let's say I want to find the value of tan 30. Well, 30 degrees is here, so the value of tan 30 will be here. Now I know that exactly 180 degrees on from that 30, so that's here at 210, I will get exactly the same value for tan as I did for 30. Now in this exam question, I'm being asked to find the values of x for which tan x is 1.1918. So I can get the first one using inverse tan. Remember that's shift tan on your calculator. And you'll get 50 degrees. Now at this point, I sort of want to draw a sketch, but remember what we just said. The nice thing about tan is that it repeats every 180 degrees. So to get the other value, I can just do 50 plus 180 and get 230 degrees. So x is equal to 50 degrees and 230 degrees. Here's one of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now here's a tricky little question for you. Before you start writing your answers down for this one, you need to remember that your values of x can only be between 0 and 360. Press pause and have a go. When you're ready for the answers, press play. So, using inverse tan, you should have found a value of x as minus 70 degrees. This isn't in our interval, so this isn't one of the answers we're allowed to write down. But remember, tan repeats itself every 180. So we can go minus 70 plus 180, and that will give us 110 degrees, and that is in our interval, so that's allowed. And then we can get that 110 and add on another 180 to get 290 degrees, which is also in our interval. If we add another 180, we'll go above 360, so these are the two answers. So x equals 110 degrees and 290 degrees.